A certain logistic company's fleet consisted of 100 Type A trucks at the beginning of 1970. At the end of each year, starting with 1970, the company retired 3 of the Type A trucks and acquired 6 new Type B trucks. How many years did it take before the number of Type A trucks left in the company's fleet was less than 50% of the fleet? There's a situation here where a company's fleet had 2 types of trucks that were changing in numbers alongside time, starting in 1970. Let's say that the total number of Type A trucks at any moment is A, and the total number of Type B trucks is B, okay? Because this will make easier to analyze our problem. Number of Type B trucks, number of Type A trucks, and let's say that at any point means that this is a variable amount that depends on the time passed ever since 1970. We're being asked how many years, right, is necessary for the Type A trucks to be less than 50% or 1/2 of the whole fleet. Okay, the whole fleet is the sum of the Type A trucks plus the Type B trucks. If we simplify this inequality a little bit, we would have 2 times A is less than A times B. In other words, A less than B. We're actually trying to find out what is the number of years that needed to pass for this condition to be true, for the number of Type A trucks to be less than the number of Type B trucks. This is what we're actually being asked. So let's find the value of T, right? Let's find the value of T, which is the number of years since 1970. Can we define the total amount of Type A trucks in terms of the number of years since 1970? Yes, because we are told that at the beginning on this year or on that year, there were 120 trucks of that type. But then, after each year passed, the company retired 3 trucks of that type. So, by retiring 3 every year, that means in 1 year they retire 3, in 2 years, 3 times 2, 6, in 3 years, 3 times 3, 9, and so on. So, after T years had passed, T times 3 trucks were retired, or 3T. So from the original number of trucks, which was 120, we would need to deduct 3 times T. On the other hand, the number of trucks of type B after T years have passed since 1970, originally there were 0 in 1970. And then each year, 6 new trucks of that type were added. So after T years, T times 6 new trucks have been added, or 6T. So let's substitute these 2 expressions for A and B in the original inequality. That represents what we're being asked, the condition to which we want to get and for which the number of years needed we're trying to find. We have 120, right? Minus 3T is less than 6T, which give us 120 is less than 3T. And we reverse this, we would have that t has to be greater than what? Notice that here, sorry, we needed to add, right? This 3t, we have to add to 60 and give 90. So it's 90 times, or 9 times t is greater than 120. 120 over 9 here on the right side. T is greater than 120 over 9. If we simplify this a little bit, we get 40 over 3, which is the same as saying, right, 13 and 1/3. So that means that the number of years necessary for this condition to be true is actually that the time passed is greater than 13.33 years. Okay, so the minimum number of complete years needed to pass is 14, right? Considering that these changes in the number of tracks are only performed, right, once a year, at the end of each year. So complete years have to pass. So that's it. This is the solution for question 5.